Итак, друзья, привет! Наш первый сегодня доклад будет на английском, поэтому плавно переключаемся. So, hey folks, welcome to Bravo Stage. Today we got out our first speaker from far, far away, exactly from Singapore. Please meet Sergii Grechukha, engineering manager from Grab company. Sergei is passionately interested in new technology, business models changing the end user life. Currently driving core mobile teams focusing on applications, build system, and developer experience of engineers. Today we're gonna listen some very special experience of Sergei on migrating entire our build system to Bazel build tool. Welcome, Sergei.
Thank you for this review and introduction, and thank you for having me here today. I'm really pleased to be here and to have an opportunity to share all experience we have here in Grab. So yeah, as it was said, I'm working here at Grab and driving the core mobile team. Our scope is really huge, I would say, and we are responsible for engineer experiences, for app health, and specifically for the build time as a part of the scope. And today we are going to talk about the specifically passenger applications at Grab and what were the challenges here. So just to give you a sense of what Grab is and what are the strategies here. In general, Grab is a super app, and we are going the strategy of providing as many of features as possible. So just to give you an understanding, we have multiple product verticals in our applications. It's transport, it's food, it's payments, deliveries, ticketing, videos, hotels, and many, many others. And today we deliver, we outserve actually our customers across all Southeast Asia, and we are live for dozens of millions of people across Southeast Asia today. To make it happen, we have a pretty significant engineering teams. We have 8 R&Ds globe-wide. It's in Singapore, Ho Chi Minh, Jakarta, Indonesia, it's India, Seattle, the USA, and others. I would say that the most interesting one is in Romania, Cluj city, which is kind of unexpected to have for Southeast Asia company. But anyway, and all those engineers are contributing to the code base on a daily basis, and we have about 3 million lines of code for each Android and iOS applications. And this kind of brings interesting challenges for us. And all of those lines, just to give you an understanding, we pack in kind of 1,000 modules on Android side and about 700 targets on iOS applications. And one of the most obvious challenges here that we face, like from the day one, is the build time. And this talk is going to be mostly about it, and we are going to dive deep into the investigations and what have we done to improve it and where do we stand today. Just to make a small spoiler, I'm going to talk about 2 platforms, Android and iOS. I'll focus more on iOS, so probably all steps are pretty much generic, and we face pretty much same problems on both platforms. So it's quite valid to talk about both of them and to compare them. So what do we have on Android? Android is pretty obvious one, and I do believe that Gradle has been made as a primary build system with us for a long time, and it's quite flexible. It gives a lot of interesting features and for reasonable cost, for really reasonable cost. But when your application passes this imaginary line of the medium-sized project to the big project, unexpectedly Gradle starts failing, and this flexibility comes with a huge cost. So to give you a sense of what costs are, for our applications today, Gradle takes 4 minutes only to go through the configuration stage of the project. I'm not talking about the build. So only configuration is 4 minutes today. And it's kind of interesting. And I would say that it impacts engineering experience tremendously. And to give you an understanding what is the build, local build time looks like on Android, it's the clean build may take hour or even more than hour today. Incremental build will take none less than 3-4 minutes. So you may imagine how huge is it. Going to iOS. iOS looks a bit better, and it seems like Xcode doing really good job caching project and delivering this good experience. But again, once we pass this imaginary border of big project and go into scaling up, somehow occasionally Xcode fails to provide the sustainable cache, and our engineers face the situation where they need to make a clean build, and once they go to the clean build, it takes half of an hour at least to compile the project and to have all binaries combined together. This is not appropriate thing to have, and this is something that we needed to change. And it might be kind of acceptable, and we may go with the local build time and suffer a bit, but then comes another challenge, and we still have CI pipeline time, and it brings another challenges. So on top of the big code base, we have a huge amount of unit tests. It's thousands of unit tests. As you may see, it's about 40,000 of unit tests, and the execution time of the unit tests usually may take tons of time. In our project, we will talk about it a bit later, but it may take 40–50% of the pipeline time. On top of the unit test execution time, we have UI tests, which also, first thing, they're slow. Second thing, we have at least 1,000 of UI tests which we need to run. And given this, we have like at least 100 of commits per day, which we would like to actually validate and make sure that we are not breaking anything and not introducing any kind of regression to our build. So given this, we needed to make some solid decisions and actually create a strategy how we're going to tackle this. And on top of all standard ways like optimizing your build graph, etc., we did everything. We did all of this standard stuff, and then the problem was that actually the scale of the project doesn't give you a really clear way to understand even your build graph. To tackle this problem, we actually introduced the concept of build time critical path. So what is it? The build time critical path is a chain of the targets or modules subsequent, which takes the longest build time. And at the end of the day, it's obvious that in an infinite number of parallel runners, in an infinite efficient and powerful environment, we couldn't make a faster build than the critical path build time. So given this concept, we have introduced the visualization tool, which actually gave an understanding to our engineers what bottlenecks they have in their build graph. So we had an opportunity to have the critical path for the whole application, and then we had a chance to have a critical path for the parts of the build graph. So we gave opportunity to tech families, to engineering teams, to actually understand what shouldn't be in this critical path, what should they avoid. Given this, we actually analyzed the whole project and traced issues and tickets to different tech families. And going back to the scale of the grabs up, we face the situation as once we scope the whole project, it happens so that the overall timeline to implement it was 6 months at least. So the whole work of optimizing the build graph took the whole company at least 6 months. And then, one may ask, and what are the results? Did you get there where you wanted? And the best thing is that no, actually we get the improvements of about, let's say, at most of 10% of the, we managed to cut the build time by 10% for both CI and local builds. And how comes? It was a reasonable question. It happens so that the optimization of the build graph is the one side of the coin, but the flip side of the coin is the actual environment where you run the build itself. And that's why we actually found ourselves in a situation where engineers' laptops were not sufficient enough. So given that we have structured our build graph in a way that we had small buildable chunks which were highly parallelized, all those tasks would simply queuing, waiting for resources to be released to actually run this task. And this is why we didn't have a huge improvement in terms of build time. Given this, we actually started thinking, okay, a local laptop is not working. Let's delegate the build. And again, going to Android, Android is pretty flexible in this case. And we managed to set up remote build infrastructure. We benefited from the AWS EC2 instances. We have a Kubernetes cluster which scales up and down, adding new instances. And we delegate almost all build to this infrastructure. What it gives? At the end of the day, it gave us huge boost in terms of build time. We managed to cut the build time by 50% the day we introduced this infrastructure. And we were really inspired by this. So we managed to cut like from, let's say, 30 minutes of build time on Android for the clean build to only 15. And it looked amazing. Same for the clean builds. And inspired by this success, we actually thought about what if we do the same stuff for iOS remote, for iOS builds. And idea was really good on paper. We actually started implementing this, and we found out that actually, even though Xcode wants to have to be in charge of everything, it wants to have the access to all processes, and it doesn't really want to delegate anything. We managed to make it work. We use the same mainframer setup. We use the same tooling. We even managed to pass back and forth indexing from the remote builds to the local machines. But the thing is that actually we have a legal boundaries and legal limitations provided by the iOS ecosystem. None of the builds can be built by not Mac machine. And this brings us to the situation where we don't really have a good choice of machines to run builds. So the best option we had was Mac Pro, right? And even though we may have like 20 plus CPUs Mac Pros with 200 GBs of RAM, the thing that we have found was that actually those Macs, they are not really suitable for the build process. They're really good for designers. They're really good for rendering graphics. But once you delegate build to this kind of machine, it sucks. What we have found? We found this, that for single build, for single user building the project, it was really nice. So we managed to have this X2 boost for the build. But once we have added the load to this machine, once we have introduced second and third user building the project, the build time get back to the equivalent numbers with the local machine. And it was kind of frustrating. So we found that the approach is simply not scalable. So at that point, we needed to abandon the idea overall and just leaving it for future. So we were in a situation where we made some improvements. Improvements were good enough, but we never got to the situation where we were really glad with our build time. In a separate stream, in a parallel work stream, we also were trying to tackle the CI pipeline time. And you all remember that we have a huge amount of tests, right? And the whole execution of the test took us about 40 to 50% of the pipeline time, which can easily be about an hour. And what could be done here, right? And probably the most obvious solution was, okay, we have a lot of tests. What if we don't run all of them? And that's where we took the idea. So what is the test impact analysis? We actually analyze what kind of changes are introduced by this merge request, and then we run only those tests which are actually impacted by the change. And at the end of the day, it gave us huge benefit. So we managed to cut 90% of the execution time for tests, especially on unit test side. The situation wasn't that nice on UI test side, though still it was really nice. And overall, for the pipeline time, we managed to cut 30% of the pipeline time, which was kind of significant, right? When you cut 30% out of 2 hours, you can feel it. You literally feel it. But again, so these were only partial solution. We still weren't there. We weren't at a situation where our engineers wouldn't sit waiting for the build time or waiting for the pipeline to actually give a fast feedback loop. And at this point, thinking about all options, we kind of found ourselves in this situation where we didn't have a lot of options. The projects are huge. Build graph optimization is kind of okay. Pipelines, we have good environment. We have powerful machines in our environment. We parallelize our tests. We delegate some work to powerful runners, but the pipeline is still bad. And it seemed to us that we needed to make some ground changes. And we needed to actually move to something absolutely different. And at this point, we kind of understood that this something different could be the build system itself. So at this point, we just ran the investigation. We compared different options, and Bazel appeared to be one of the best options for us. And there were reasons, right? So one of those reasons was the Bazel enables remote builds out of box. So you literally don't need to do anything. You may just get like predefined Docker images and run your builds on those Docker images whenever you put it. Well, it doesn't really work for iOS. It's still, we have these limitations, but on Android side, it works perfectly. We don't need to reinvent the wheel. We just simply run it. Another and really game-changing feature of Bazel is the sustainable cache. And here, I think we should talk more about it. In general, the best cache ratio that we can hit on Android build as of today is about 60–70%. On iOS, it might be better for local builds, but still, Xcode may screw your cache at one point, and you still need to rerun your build and make it clean, right? And in terms of Bazel cache is really sustainable. So you don't find your situation when you need to do clean build. And this saves you time. Another benefit of this cache was that this cache actually may be reused. So today we are not reusing any of cache for iOS builds. We have separate local cache for local builds. We have clean builds for CI. And it brings us to the situation where each time we run CI build, we run it clean. In the case of Bazel, we can simply reuse the cache. And again, on CI, we won't have a clean build. We will have just incremental build. And on top of this, the whole idea of Bazel was to work with the big code bases. The whole Google monorepo is compiled by Bazel, and it has millions and millions of lines of code. And the whole Bazel stuff was designed in a way to maintain this code base. And another side effect of Bazel was that actually we could reuse multiple tools for both platforms. So we didn't need to write different tools for Android and for iOS. We could reuse whatever we have for metrics collection, for pipeline setup, etc., etc. And given this, it was kind of an interesting idea. And we started playing with this idea. We started planning. And we spent about 4 to 5 months just to understand what kind of blockers we may have to migrate our apps to Bazel. What kind of things we will need to tackle on this way. We actually created a proof of concept, and the proof of concept was really nice. So it gave us nice incremental build time. We never faced the situation where we needed to have a clean build, etc., etc. But the problem came with the scale again. So given 3 million lines of code, hundreds of targets, multiple technical families, like dozens of them, the whole migration cannot happen in a night. It's not a single shot migration. And given our estimations, it happens so that the whole migration will take us years. So literally years. The estimations showed us that we needed to spend 90 person months to do the migration for one platform. And given it's two, Android and iOS, it will take us about 200 person months just for simple migration. And when you come with these ideas to your stakeholders and to C-level folks, they simply don't understand it. So they don't get the reasoning behind it. Everything was working. Yes, it wasn't working ideally, but still, we still deliver our feature to our customers. We still do the great job. Our customers are still happy. Why should we change something? Why should we ever invest in this? So to get this, buy-in from all stakeholders, we actually grouped those stakeholders in the different categories. One of those categories was C-level stakeholders. It was CTOs, it was co-founders, it was C-board. And we defined the key areas where we needed to make commitments and where we needed to provide some understandable metrics, why it's needed, and what we may commit for. So for stakeholders, it was obvious. It is impact, right? So in terms of impact, we said that we are expecting to cut the build time for another 40%. What it gives? Well, it's all simple, right? So when you cut the idle time of your engineer waiting for another build, you simply cut the engineering time overall. And our estimations showed us that in general, we could cut about 10% of engineering time only because of this improvement, which is cost. And which goes to the second clause where we brought the investment gain. We showed that in a long run, in a year, we will have a turnaround and we will have a payback from this investment. Given the improvement of the build time, given the improvement of the idle time, this initiative will pay back in a year, which was already reasonable, quite reasonable for stakeholders, for C-level folks. And then the last one was we committed to not compromise the engineering experience. So we needed to make sure that our engineers have the same experience in terms of IDE, in terms of the routines that they got used to. Given this, stakeholders were kind of happy with it. So they're saving money, right? In a year, they have a payback, and then they simply get gains from these investments. Looks good. And then they have also commitments that engineers are also happy. And after this, we go to engineers. So this is another group that we needed to make happy. And here, I think the major factor for engineers was, again, engineering experience. So we had multiple talks with our engineers where we explained that whenever we have Bazel all native, we will have pretty much same experience. You will still have this big green play button, which you press and you have your app installed on your simulator or device and working. So given this agreement, we got buy-in from engineers. And there were a couple of additional things we needed to make sure that happen. First, early adopters. So we needed to get early adopters from the engineering community. We needed to have like a core experience group, which will support us on the later stages, which will be advocate of those technology, and which will actually be our, adopters, providing this knowledge into their tech families, into their tech teams. And then, given we have those adopters, given we have those priests of knowledge, we committed to provide the educational programs for our engineers, which also included workshops, guidelines, documentation, tech talks, and so on and so forth. And then we had another group of stakeholders which we needed to talk to and also get buy-in, because we are a product company. The ultimate goal of Grab is to outserve our customers. And product folks are kind of the cornerstone of this. So we needed to make sure that even we do this mass migration, even we are changing the core component of the whole application, we are not changing anything and we are not impacting the product roadmap. And this one was challenging, frankly. I will make some notes on this bit later. And then it's quite obvious, right? For product teams, for product managers, it was really crucial that engineering effort is not minimized for them. So they still have the defined capacity of engineering teams to deliver this roadmap. Given all these items and given all these key factors, we found ourselves in a situation where, okay, from one side, we had a huge estimation of the project. We believe that it will take years, right? And it didn't work. So we had a strong pushback from all groups of our stakeholders. Well, maybe engineers were not pushing back that much because they were interested in technologies. But C-level and product guys clearly said, no, it simply impacts our roadmap in a way that we won't be able to compete against our counterparts. And it was reasonable. And at this point, we took the feedback in, and we didn't have a lot of choice. We needed to regroup and actually to rethink what could be the approach, what we may change. At this point, we started considering the idea, what if we automate the process? What if we are not doing it module by module, target by target, just simply introducing Bazel build files and going from leaf modules to the top level modules. But what if we introduce a concept of hybrid build, where we may migrate just a couple of modules out of the whole dependency tree and make working native build system with Bazel build system alongside. So we still have a primary build system, which is going to be native one, and it will simply accommodate the Bazel one. Given this concept, we actually enabled ourselves to go in a pace, in a velocity, which we choose. So even though we have some blockers, we had our time to resolve those blockers, resolve it, and move forward. It looked good, but it still was really slow. It still was years of engineering work. It was still years of engineering efforts, and it still had the pushback. So another part of the thinking and another stream was for us how to automate the project, how to automate this migration. And it was quite obvious, right? Why not to simply read the project structure and simply mimic it, create an equivalent Bazel setup? Given this concept, we built a proof of concept, which actually showed that this is quite feasible. On Android side, we even created a Gradle plugin, which easily migrates some sample projects on the internet provided by Google. In a single click, in a single command, it simply migrates. Just as a spoiler, we are going to talk about this tool on Bazel Conf this year. But anyway, on iOS side, it wasn't that straightforward. So on iOS side, we needed to tweak a project a bit. We needed to move some files. We needed to restructure the project. But still, it's quite automatable work. We could manage to automate it. And in 2 to 3 months, we managed to create tools for both Android and for iOS, which were actually able to migrate target by target automatically. Again, single command migrates everything. And then you simply benefit. The reality is today we are not at the status where we have migrated everything, but today we are at the stage where we confidently say that we may migrate 70%, 100% of the code base in a reasonable amount of time. By reasonable amount of time, I mean like in 2 to 3 months. And this work can be easily done with a small group of people. So by simply introducing this automation tooling, the simplest estimation showed us that we may cut at least 50% of the estimated costs, and we may even go beyond this, which already removes the key factor for C-level stakeholders, and it was a good sign for them to give a green light and actually to allow this work. On top of this, as I said, the whole migration could be managed by a small group of people. So literally 2 to 3 people on each platform 2 to 3 persons on each platform could easily do the whole migration. The only support which we need today from all variety of tech families, from all other engineers, is simply review merge request, simply learn about Bazel. But you literally don't need to do anything, which sounds like amazing. And finally, given this, we do not have any impact on roadmap, on product roadmap. So product is developed in a way it got used to be developed previously. All engineers who have been involved in the product development, they are still there. We are not cutting any time from those people. We simply seek for minor support. So the major work is done by the small, limited group of people which are not involved in the product development and wasn't involved before. And yeah, given this, sorry, given this, we are going to open source both of those tools. Android one looks a bit better. It looks like more decoupled from the whatever we have internally. And I believe that by November, or let's say by the end of this year, we are definitely going to open source this tool. And maybe your colleagues will be able to use it. On iOS one, we will need to spend some time to actually decouple it from the whatever we have, and still we are going to open source. I believe it's going to happen somewhere in spring next year. So just wrapping it up and trying to answer the simple question: is it worth of it at all? As of today, we've spent like 9 months doing this initiative and actually migrating the project. And looking retrospectively back, answering a couple simple questions, right? And the whole migration, it brings tons of edge cases. There were dozens and dozens of issues that we haven't seen before. You can't actually find those issues on Stack Overflow. You need to go really deep into the build systems to understand what doesn't work and what should be changed. So it brings a huge complexity. And actually, you don't have any sources to resolve it. Even though it's Bazel is kind of coming from Google, right? And we're expecting to have a bit more support in terms of Android Bazel rules. But no, there are only basic support, and the whole idea of Google is that the Bazel should be supported by community. And here we go with community, so we shouldn't be expecting for any support. This boiled down to the cases where we actually implemented features which are required by industry, and it wasn't present before. On iOS, situation is even worse. So we have really basic rules. Either we use those rules, either we adapt our project to comply with those rules, or you need to go with your own solutions. I think one of the biggest challenge for us, or maybe not biggest, but one of the big challenges for us was we needed to adopt such, you may think about the obvious thing like indexing, right? So once you delegate the build to Bazel, you need to get indexing. So Xcode simply skips this part of your code, and it simply won't have such features for this code as jump to definition, code complete, etc., debugging. And we needed to somehow bring this indexing from the Bazel build parts to the Xcode build parts to provide this flawless experience in the hybrid build, which you couldn't really Google it. Another one is that Bazel is not absolutely industry standard, and if you would like to go to Bazel, you will have a hard time hiring people. There are no good specialists there. I mean, there are good specialists in Bazel, but they're working in Lyft, they're working in Facebook, they're working in Grab, but you can't really easily hire those people. And again, if you're going with a small or medium projects, it's totally not worth of it. Go with native, do native. Native is quite flexible. It's really user-friendly, and it doesn't give you all these overheads that we have. But once you move to the bigger project, it's probably becoming essential. So in our situation, we simply hit the top bar of native build system. We hit a top bar of environment where we build, and we just simply don't have other choice than moving to something different. And if asking me today whether we would go this path again, well, it's definitely yes. We definitely see the improvements, and even today we have like 20 to 30% of the code base migrated. We already see the benefits. We already got the local build time. We already benefit from the cache, which we actually may reuse from CI to local builds on iOS, which is amazing. And we are really excited by this. And I think by the end of this year, we will have even better results. And we are inspired with those results. And the answer is definitely yes. So at this point, I think I will be really glad to answer your questions, to get any feedback or your ideas, folks. Actually, your ideas even more appreciated because we're kind of in a edge case scenario where any idea matters. And yep, feel free to reach out to me. I'll be glad answering your questions offline. And if you're interested in working at Grab, yep, you may find this slide, and feel free to reach out to our talent acquisition people. Thank you.
Thank you. Great lecture. So guys, on the right side of the screen, you see the questions and answer section. You're able to ask any questions to the Sergii. And while you are doing this, so a few questions. How fast Bazel is growing as a tool?
In general, it grows pretty fast. But again, it highly depends on the company and on the on apps you consider. So today, Facebook is also considering migrating to Bazel. Well, in general, they have Bug. Bug is kind of same, but they are moving to Bazel. Spotify moving to Bazel as well. Lyft is already there, and so on and so forth. So the list is pretty extensive. And again, it really depends on the app. If you're working in a medium-sized level app, you're not interested in it at all. If you're working in something big, yep, it grows really fast.
Another questions from the Mikhail. So hello, great topic. Thanks. Question: how do you manage dependencies? CocoaPod, but Google says that there is no official support for it.
Right. So in general, we either precompile whatever is not manageable, and then we simply use binary, or there are some custom rules for it. And again, the rule of thumb for us: if there is nothing already provided, the first thing we consider may be implemented ourselves. So in general, it's the way like this. You don't have it, you implement it.
Okay. Are there any issue related to platform updates when Apple released some changes in the build system or something else? How Bazel handle this?
Thank you for this question. It's a really nice question in general. So right now we are in the middle of migrating to Xcode 12, and probably it will give a couple of surprises for us, and I do anticipate that it will happen. In general, again, Google is not supporting Bazel actively. So whatever you face, you're on your own. And this should be considered before you actually start working with Bazel. We are kind of okay as of now. We don't anticipate any huge problems with it. But yep, this is the risk that you should take.
How much time do you spend on the migrating from Xcode 11 to Xcode 12?
It's really nice question. So just to give you a sense, it's months.
Mm-hmm.
Let me elaborate here. So as I said, we have a really distributed horizontal team structures. And to simply migrate to new Xcode version, we need to make sure that first we have a CI environment which supports this. Secondly, we need to understand that all breaking changes are handled by separate independent teams. Given this, we move in steps. So step number one for us is to actually create the environment and point out all breaking issues for different tech families. Given this, we delegate fixing those issues to different tech families and wait for them to fix. And this takes time because we need to accommodate this work with the product development as well. And then once all tech families give their go, we wrap things up, make sure that everything works, do regression, and then we are live. In general, it takes months.
If we compare the native migration, for example, if you don't use Bazel and you're migrating from Xcode 10 to 12 or to 11, or when we compare when you have Bazel and we're migrating from Xcode 11 to 12, what's the difference in this time when you use Bazel or not use Bazel?
Right.
What do you think?
Thank you. So the good thing is we created this concept of hybrid build, which simply has, in a nutshell, it just has a build phase step, which consumes Bazel binary or whatever Bazel produces. This means that in general, we don't change a lot based on the Xcode. In theory. On practice, it may differ. So it brings my answer to the simple, it doesn't matter whether we have Bazel or not. But there can be edge cases.
Okay, thank you. We've got another question. So could you compare it with mainframer? In that case, problem could be solved for Android part and left to solve only the iOS part.
Right. So mainframer helps us a lot. As I said, for Android, we have non-mainframer build, which may take hour. Today, it's hour. On mainframer and really powerful EC2 instances, it takes about 10 minutes, maybe 20 minutes at most. And it's kind of reasonable, it's kind of okay, but given our migration today, Android is a bit ahead of iOS. We have on Android about 40% of the code base already migrated, and we may actually run builds. What we may see is that this 40% of the code base migrated to Bazel and cached, given it's on local disk cache, we may compile those 40% of the code base in 30 seconds. And it's considered to be clean build. So now compare it to the 20, 30 minutes on mainframer. It simply just outperforms.
Thank you that you shared that great experience with us. You are first person who migrated to Bazel, as I know. So, so thank you for that experience. It was great. And I will switch to the Russian language. Друзья, напоминаю вам, что наш следующий доклад начнется ровно в 12:30. Будем ждать вас на нашем Браво стейдже. Во время перерыва загляните в выставку партнеров Virtual Expo. Там интересные квизы и розыгрыш призов. Так что всем удачи. Спасибо за доклад.
Спасибо.